Hi, I'm Kurt with Travers Tool Company. Today I'm going to talk about drills. Not so much how to use them, although I will give basic tips along the way, but we have another video for that. There are so many different types of drills, different sizes of drills, different features in each drill. I thought I'd just stand here and show them to you and talk about them and just try to help you a little bit in deciding what type of a drill you might need for your particular operation. So anyway, let's get started. So what's the anatomy of a drill? So I'm going to take this bigger one here because it's easy to see. So the ground out parts of the drill is the flute. We have the cutting tip, the little piece, the chisel point that's between, let me see if I can get that closer. So this part of the drill is the web or chisel point. It's called different things. This is the margin along the side. So that's a pretty big drill. And obviously the shank is down this end. And the shanks vary quite a bit too. Anyway, so that's one example. The sizes of drills. So let's see if I can remember them all. So there's obviously metric, standard, which is fractions. There's decimal sizes. So in case the standard fractions or metric isn't enough, you need something in between. We have decimal sizes. There's letter sizes from A through Z and number sizes from 0 through 80, but really it's the 0 through 60 that's more common. A weird thing about the number and letter size drills is that we have the letters from A to Z, and the A is the smallest, the Z is the biggest. Okay, that makes sense, right? Well, on the number size drills, it's the number 1 that's the biggest, and the number 80 that's the smallest by far. So we go from 80 up to 1 to number 1, and then the letters take over. So the next bigger size between numbers and letters is the A. So we go from number 80 up to number 1, switch to letters, and go from A up to number Z, and then the Z is the largest of the bunch. So a little bit confusing. So that's kind of why I wanted to explain that. So that's the different size drills. We have different drill points. Okay, so there's the difference between a 118 degree, which is this one, and a 135 degree, which is that one. So you can see how the 135 degree is much flatter in contrast to the pointier 118. So the 135, sometimes some of them are 140, maybe 142, is usually used for harder materials, and you can get them in a split point. As you can see here, oops, where's the camera? There we go. The point is, trying to get the focus here, the point is split so that that web that I showed you before on that great big drill is basically gone, and there's no chisel point on it. All right, let's talk about tool materials. So the main three in tool materials is high-speed steel. That's the most economical, kind of general purpose. Next is cobalt, a little bit harder. You can get into harder materials like stainless steel, perhaps, with the cobalt drills. And then the solid carbide, which is very high-end, usually more expensive, especially when you get up into the larger sizes. So as you move away from high-speed steel up to carbide, as I mentioned, they get harder. The problem with getting harder is they become more brittle. So if you're using, let's just say, a small diameter carbide drill in a hand drill, it's brittle. So if you move your hand around as you're drilling, you could snap the drill bit. Whereas if you're using a high-speed steel drill, it might not snap because it's a little more forgiving. So high-speed steel is more economical, a little bit more forgiving, but it'll wear out faster. Carbide, on the other hand, will last forever if used correctly. You need to use a lot of care with them, but they're a lot harder. They are more expensive. Great option if you need it. And then cobalt is somewhere in between the two. Then we have finish coatings. So here's an example, a couple of examples of no coating at all. They just call that a bright finish. It's just nice and shiny. They might polish this as they manufacture it, but we just call that a bright finish. If you ever see that in our catalog or on our website, that some cutting tool has a bright finish, it just means it's uncoated. And here we have an aluminum titanium nitride, or ALTIN. Here's a titanium aluminum nitride, or TiALN. And there's just a titanium nitride, or TiN. So very different kind of coatings. And that's just a few of them, the more common ones. But there are some others. All right, let's see. Coatings. Okay, so let's get into the types of drills. First, we're going to start with the one I just showed you that has the TiN coating on it. Now, in contrast, you see the difference? You see how deep the flutes are cut in this drill on my left, on your right? That those deep flutes are what make this a parabolic drill. So the purpose of or the reason to use a parabolic drill is if you're going into a deeper hole. There's lots of room in the flutes for chip evacuation. So the chips don't bind up and bunch up in there, and they come out a lot easier. So typically when you drill, you have to do what they call peck drilling. So you come down a little bit, bring the drill out, let the chips evacuate when you're deep hole drilling anyway. Come down a little bit more and just take a peck at it, bring it out, let the chips evacuate, and so on. So with that parabolic drill, you won't need to do that nearly as much because there's so much room in there for the chips. We have a half round drill, which is half round. So it doesn't look like it would serve much purpose, but it actually does. If you're drilling soft material, say rubber or a thin plastic, something that when you have these spiral flutes, as you're drilling down, it's going to want to pull the material up. Well, if you use a half round drill, there's no spiral on it, so it doesn't pull the material up. It's a perfect solution. And by the way, another solution is a straight flute drill. It doesn't pull the material up and gives you a nice clean hole. Next one on my list is technically called a combination drill and countersink. I've never heard anybody in real life actually call it that. It's a center drill. So the reason it's called a center drill, that's kind of its nickname, but the reason it's called that is because usually, but not always, this is a 60-degree angle on the sides here. So if you put this in the tailstock of your lathe and drill a hole in your workpiece, now you have a 60-degree pocket in your workpiece that you can put into a live center and turn a longer workpiece and hold the back of it with the live center and the other side of it with your chuck. So you can use it as a combination drill and countersink, but you don't really countersink 60 degrees too much. So they are available in other angles, but sometimes they're also used or misused. I guess it works okay, but as a spotting drill. So it's so short and so rigid that you can put a small hole in your workpiece before you follow it up with a drill bit like we have over here. So it just helps to keep it centered. There is a better tool for that though, but this is commonly used for a spotting drill. Proper use is to be used as a center drill, but it is called a combination drill and countersink. So confused yet? Don't worry. There's more confusion to come. Actually, I'll try to keep it less confusing. Let's see how I do. Okay. Next is a core drill. Here's where the core drill is. This is just a very small one. They come in larger sizes. You can see with this core drill, you can see there's no point on it. So this cannot drill a hole that does not have a starter hole already in it. This will only open a hole to the diameter of the core drill itself. So another hole has to go in there first in order to be used for a core drill. So if you know what a reamer is, a core drill is kind of like a reamer on steroids. It takes a lot more material away. It's not quite as accurate as a reamer, but it's more accurate than a drill. So that's what a core drill is. Next, we have an extra long drill. I kind of have to step away from the camera a little bit to get this whole thing in the picture. It's a 1/2 inch diameter, 18 inches long. So if you have super deep holes and you need to use an extended reach drill, best thing to do is don't start with a drill this long. Start with a maybe a spotting drill, then a stub length drill, maybe a jobber's length drill. We'll get into those in a minute. But this should be the last drill in length because of its length that you should use. So you should never use a long drill to start a hole with. Kind of common sense, but maybe somebody didn't know that. So there it is. Most common length of drill is a jobber's drill. So there's an example of a 1/2 inch jobber's drill. And the smaller the diameter gets on the jobber's drill, the shorter the length also gets. So say a 1/16 jobber's drill might just be less than half this length, but they go up typically to a 1/2 inch, sometimes go a little bit larger than that, but most common of all of them in length is called the jobber's length drill. A masonry drill. It works like garbage in steel. It doesn't work very well at all. You can probably see that point is really dull, but it's a carbide tipped, not very well polished, but you know what? It doesn't need to be. It's just kind of a rough drill. Works great in cement or brick, stuff like that. Works horrible in metal. Totally not made for that purpose though. So they have different shanks on them. This particular one is a straight shank, or actually it's a reduced shank, because you can see the shank is smaller than the body of the drill. But anyway, that's a masonry bit. Next we have a mechanic's length drill. So in comparison to a jobber's length, with the bottom of them lined up, you can see the mechanic's length in the same size. Both of these drills are a 1/2 inch diameter. The jobber's length is a little bit longer than the mechanic's length. So whenever something's shorter, it's a little more rigid, a little stronger. All right, I hesitated to bring this drill, get it up here where you can see it, to bring this drill home from work because it's so fragile. It's so small. I mean, can you even see that in there? So there's a shank. There's a 1/8 shank on this thing, and then what you can't see, I can't see that it's even on there. There's a drill on here. The drill is less than 4 thousandths in diameter. So if you pull out one of your hairs and measure it with calipers or something, you'll find it's around 4 thousandths. This drill is just a little bit smaller than the hair on your head. If you can even imagine, people are drilling holes. I've never drilled a hole that small. Smallest I've ever gone is about 18 thousandths. But, and that was tricky enough. But a drill that's less than 4 thousandths of an inch, and they're in stock if you need it. I hope you don't, but if you do, we got you covered. Okay, so that's a micro drill for obvious reasons. Then we have a reduced shank drill. All right, so here's a reduced shank. I also mentioned that for our masonry bit. It's a reduced shank because the shank is straight, just like on this one. The shank is straight, but you can't call it a straight shank because technically this is a straight shank drill. So when you hear the word straight shank, you should automatically think that the shank is the same diameter as the cutting end. That's a true straight shank drill. Now this shank is straight, not really called a straight shank though, because it's a different size than the drill body. So that's a reduced shank, otherwise known as a silver and Deming drill, or I've heard them just called a Deming drill before. The technical term is silver and Deming drill. That's what they're called. Now, something about this particular one that I have, a couple of things about it. You can see it has that split point on it, 135-degree split point. So that's a real nice feature. That, by the way, just keeps it from walking, creates less pressure on them. But what I like about this drill, if you can see that, it's got 3 flats around the shank. So when you chuck this in, let's just say your hand drill, a couple of nice things about the flats is that there are 3 of them. So your the chuck in your hand drill has 3 jaws on it, and they'll grab right on those flats. This shank will not slip in your drill. The problem with that is if it gets hung up, if this is going into a hole and it gets caught on something, you could twist your wrist pretty severely because this is not going to give. All right, so it's good that it won't slip, but it's bad because you could hurt yourself. So be careful when you use it. Okay, another good thing about those flats is that when you clamp the shank of a drill in your chuck, the chuck has hardened jaws, so it leaves marks on the shank. That's okay. The shanks are soft. They're meant for that, and that grips the shank a little bit. But when you do that, and then if you want to put the same drill in your milling machine, let's just say, for example, and you want to put it up in a collet, the collet is round. And if on the shank you have a lot of burrs from holding it in your chuck, it's not going to hold true because the inside of that collet is round and it's going to be gripping on those burrs. So what's nice about the 3 flats is all the burrs are going to be contained inside the flat. Therefore, when you put this up into a collet, the collet is only going to touch the round surfaces and just stay away from all those burrs on the flat. So any reduced shank drill I have has those 3 flats on it. I love it. I don't understand the purpose of not having them. So huge benefit there for a couple of reasons. Next one on the list is a stub length drill bit. You can see how short this is. So it makes a great starter drill or even a spotting drill because the shorter it is, the more rigid it is, right? We already talked about that. So if you're drilling shallow holes or drilling through a workpiece that isn't very thick and you're going all the way through it, this is probably the only drill that you need. You don't need to drill a starter hole and then follow it up with a drill bit. Just use this one. You have one operation, your hole is done. Okay, another drill we have here is a different type of length. This is called a taper length drill. So this is between a jobber's length drill. Okay, where's that mechanic's length drill? There it is. Here's our mechanics length drill. Right here, our jobber's length drill, taper length drill, just a little bit longer. And then our extra long drill, it doesn't even fit on the camera. There it is. Okay, so taper, if you need something longer than a jobber's length drill, the taper length might be just the answer for you. Here's a spade drill. Doesn't have spiral flutes on it at all. Just kind of looks like a chisel or maybe a center punch or something like that. That's actually a drill. It makes a perfect starter drill or spotting drill, I should say. But it's called a spade drill because of the shape of the tip on it. And this one is actually an honest to goodness spotting drill. You can see there's no relief around the sides. It's not really intended to go very deep into a hole. It's mainly just short and rigid, has a long shank on it and short flutes. But this is designed just to start, just get a little dimple, little spot in the workpiece, so that you use another drill to drill your hole. And this will ensure, as some of the other ones will too, will ensure that your hole is going to be in the right place. So it'll prevent the next drill from walking around, from just kind of moving around on the workpiece. And then when you start plunging into it, who knows where the plunge starts. Will it be in the right place? Maybe, maybe not. So this will keep it in the right place. This one is different. This is, so you might want to say this drill is pointless. Sorry about that. It doesn't have a point on it. There is a very good point to this drill though. Very high end, very high precision actually. You wouldn't think so, being it's a flat point. Tons of benefits to this drill though. First of all, it's solid carbide, so you have to treat it with care. Has a very exotic coating on it. You can see that that blue kind of purplish coating on there. Here's what this thing can do. So if you have an uneven surface, or you're starting a hole off center on something round, but you're starting a hole where it's not an even surface, and the drill, when you start the hole, it's going to walk. Maybe it's a ramp or the radius like I mentioned, and you know the drill is going to just walk off that part and down to the side. So the solution for that takes a little time. So what you do is get an end mill that obviously has a flat on it, similar to that, and you'd start the hole with an end mill just to create a flat in it, because you can't start a drill that's going down on an angle. All right, so you have your end mill. Have to do this in a milling machine, obviously. Could do it in a drill press, but a milling machine is better. So you have your flat that you just put there with your end mill. Then you grab your starter drill or your spotting drill, and you put a little hole in there. And then finally, you get your jobber's drill or whichever other one you're using, and then you put your hole. Or you could grab one of these, not just any flat drill, okay, but this particular type. This is a Nachi, is the name brand. I don't know of anyone else that's actually making these things that are effective, and these work fantastic. So you have an uneven surface, a sloped surface, a radius surface, anything like that. This can come down on the edge of it, and it'll go straight in. There's no walking, no muss, no fuss. And besides that, if you've ever drilled through all the way through a workpiece, so drill a through hole as opposed to a blind hole, you'd notice that coming out the bottom of the workpiece, you're going to have a lot of burrs. This does not do that. This leaves it's a sharper edge, you know, than something before you deburr it, obviously, but it doesn't leave the burrs like all of these other drills will. So very high end. It's on the pricey side, I'll warn you ahead of time, but it's a time saver. And if high volume production work is what you do, and you have an issue where you have to start a hole on an uneven surface, that might just be a wonderful answer for you. So I hope you got something out of this video. I hope I explained satisfactorily about some of the features, different types of drills, different sizes, and so on. If you have any questions, feel free to email us at Travers, give us a phone call, talk to somebody, me or somebody else in tech support there. Even our sales staff, they're pretty sharp. So we welcome your questions is what I'm trying to say. So reach out to us. But anyway, thank you for watching, and if you have any comments that you want to include below, maybe there's something that I left out, let the other viewers know by leaving a comment right in the comment section of the video. So again, thanks for watching, and stay tuned, see what's coming up next.